let me first introduce myself. I am Oscar Martinez, and he's Marc Guirao. We both work in ClearPix. There is a couple of slides about ClearPix coming now. Me and another colleague of ClearPix, Danny Ramirez, we were here in the Cloudera Day today. Well, there was, maybe some of you don't know, but there was a Cloudera Partner Accelerator Day that just finished 1 hour ago. It was very, very interesting because, well, as most of you, I think everybody in the room knows that Cloudera and Hortonworks merged. And there were a lot, there still are a lot of questions, but most of them were solved today, at least from a conceptual point of view. No, like, will it be a Cloudera a CDH7 or what will happen? So we found a lot of answers today, which is pretty cool, and stuff about what the services are. No, but we all know about the Hive LL. The Hive long live and process versus Impala fight. So what will happen? No? Is Impala winning? Is Hive winning? Apparently they are both winning. They're keeping both. And there is some cool stuff that we will see in the coming months. There will be later this year there will be a first release of the Cloudera Data Platform. That's the name of the new distribution of Hadoop that these guys are putting together. And slowly it will incorporate more and more of these announced features that we learned today. So I'm very excited personally. I've been working on big data and on Hadoop for a while, and this is really one of the very nice moments in the big data history. Anyway, just wanted to share the excitement of what I learned today. I've been spending all my day writing about, oh, these guys are doing this. Actually, I started sending pictures to our marketing there, which is there, Julie and Joanna. And at some point, I said, okay, don't tweet everything I'm sending, because you know what? I'm going to just write an article about what I learned today. So we will be publishing an article about what we learned today about this Cloudera data platform, which is super exciting. Anyway, I'm going to now start officially this meetup. I thank a lot Yelena and Cloudera for inviting us to host this event. And well, let's get started. First, we're going to talk a bit. I'm going to introduce you ClearPix. For the ones that don't know, I think everybody should know ClearPix by now, but just in case, I'm going to introduce us. I'm going to talk about the evolution of enterprise data analytics architectures. I mean, what people were doing when they wanted to do analytics on business data and what that they are doing today. This is changing, and basically what I'm going to say is a bit outdated compared to what I learned 2 hours ago. But you know, keep updating the message as it goes. And then the main core of the meetup is to show you guys some tools and methods that we have been using in-house and that we are proposing to our customers to help you when you are dealing with these huge clusters with a lot of nodes that are Cloudera. Okay, Cloudera or Hortonworks DP before, they are tools with plenty of services that allow you to do many different workloads, from ingestion to streaming to data analytics platforms, data warehousing now, operational databases, machine learning. Okay, it has the engine to do all these things, but operating these engines, come on, let's be honest, sometimes it's like really, really hard. Okay, and we all know that. We all know that, you know, not everybody loves to type some old Spark code, you know, old-fashioned. I'm typing, so people like easy to do stuff. People like easy interfaces, and we encounter that a lot in our customers, that they just need tools that facilitate dealing with these clusters. In some cases, as I was talking with some colleagues guys from India, from one of the largest e-commerce companies, that they actually have the other way around. No? The Cloudera or the HDP in your case was so slow in fixing bugs that they are ending up going through their own open source. They are getting the open source. And it's really shocking. That's why I'm sharing it, because learning that there are actually people with a really, really large cluster that they are gonna drop, you know, Hadoop distributions of Cloudera or Hortonworks, that they are gonna go with the open source and maintaining their own. For me, it was a bit of a shock. It's like, oh, actually, this is actually something that there are guys doing it because you have your own very good reasons, I think, no? Anyway, so I'm gonna just slowly build up until the moment I'm gonna start talking about all these different tools that may help you. Some of them may not help your particular case because you already have it covered. Some others may open your eyes, I hope. And in any case, talk to us, okay? Talk to ClearPix, talk to the experts. If you, at the end of this, we're gonna be around until 8:30, so we just talk and I can give you my card, not my credit card, my business card. And we can discuss about how we can help and, well, whatever. During the following 40 minutes, 50 maybe, I'm gonna talk a lot. I'm gonna also demo a few of these tools, okay? So you get a first look of how some of these tools work. In the room, we have with us also guys from Arcadia Data, which is one of the tools that we will be demoing. And okay, I'm gonna say more about Arcadia Data later, okay? But they are around. There are a bunch of t-shirts there, very cool baseball-like t-shirts. I'm gonna take a lot of them for my team, but probably I can leave a bit for some of you if you want them, okay? Okay, ClearPix. We do data analytics, okay? We are a company specialized on what before used to be business intelligence. Now it's more broader term called data analytics. So we do from the traditional BI stuff, like descriptive analytics, with traditional data warehouse technologies, but also with big data technologies like a Hadoop cluster, or distributed databases, or massively parallel databases like Teradata, Exadata, all these kind of things. And also a lot of, we all know this is a trend now, all the machine learning. Everybody's talking machine learning. Everybody's doing artificial intelligence. So we do all this, okay? And we do it in the cloud, on premise. So we are basically just doing data analytics in the broader term of it. So we are almost 20 years old. We have been working in many different projects in different countries, in a lot of verticals. We are not focused on a single vertical, not at all. We've worked with many different customers. What they all share, they are all analytics problems. So we are an analytics company that do analytics projects, okay? Our headquarters is here in Barcelona. So we are very happy that Hortonworks now Cloud Data chose Barcelona as the place to have this, because we are playing local now. So it's pretty cool. We also are very active, and we actually have offices in Dubai and Abu Dhabi. And from April, May, we also will have office in Boston, in US. So we will cover the whole planet. We are still small, okay? So we are around 80 consultants. So we've done, that's our size. I mean, I'm not gonna lie. Certifications. We have our fetish technologies, but we are quite agnostic. Okay. In the end, we are partners with Arcadia, with Zoom Data, with Power BI, with Tableau, with Click. We are partners with all these technologies, and since we know them, we know that they have specific use cases and places where you say, okay, this is the place for Arcadia Data. Okay, so we are happy with that multi-technology approach, and the same applies to the other more back-end oriented tools, okay? There are a lot of tools out there. You probably have heard millions of names. We also have heard millions of names. We have touched a lot of them, and depending on the customer, because every customer is unique, no? We suggest one or the other. This is our circle of life. We go from the very early phase of a data analytics project, the early conversation, the strategic definition, the planning, then the actual deployment of whatever cloud or on-premise data analytics platform, in a hybrid, whatever, okay? And then we start implementing the actual use cases, analytic use cases, okay? The more descriptive oriented or the more advanced analytics with all the artificial intelligence, the machine learning stuff, okay? With whatever engine that we need, be it a data warehouse, a normal data warehouse in one small server, or a very big cloud data deployment. Okay, now I'm gonna start going into the direction of what I wanted to share with you today. So probably all of you are familiar with this architecture. The ones that have been working on analytics probably have seen variants of this thousands of times, no? The traditional BI picture, no? So we have structured data on relational databases, our CRMs, our ERPs, all these things. We batch ingested this into a data warehouse via a ETL tool, a separate engine that all the data flows there, it's transformed and dumped into the data warehouse, and in some cases with an ELT tool. So the data goes in the staging area on the data warehouse, transform. You are probably familiar with all this, no? And then we have the data is, all the data that is going to be used for analytics is shaped into nice star schema models, and then we have our analytics tools sucking it out to print very nice dashboards, no? So this is the old way. Still a lot of projects on this, by the way. So this has been evolving and into something that we could say a modern data analytics platform, which combines the typical BI enterprise data warehouse with big data platforms plus machine learning use cases, okay? And this more or less looks like this. Okay, this is just one. It pretends to be a template, but we can actually make it a bit, a lot of changes depending on the case, no? But on to our structured data, which now may be very big. We also add the unstructured data. And then we have our old batch ingestion pipelines, but also real-time ingestions. And then all this information flows into a thing, okay? That thing is here represented with something that resembles a database plus a lake plus a flow. So it's this platform that, in the end, we know that it's basically a Cloudera, no? That it has Kafka, it has HDFS, Kudo, it has all these things for all the different workloads. Okay, once the data is there, you have different engines that will be processing the data, writing it back, or writing it in some specialized data marts, also within the same platform with some Parquet, with a nice partition, especially optimized for data analytics dashboard. Okay, but in the end, everything stays in that big data platform. Since there were, I'm going to be changing a bit so you guys see me as well. It's the same pic, no? It's the same, yeah. So now it feels weird changing this. Maybe I go back there. Nah, I stay here. We also see a lot of people that want to keep the separate data warehouse. We'll see our friends from the, what was the name of your company? Sorry? For Flipkart, or friends from Flipkart, they still have their Vertica, no? Was it Vertica? So they have their big data cluster, a huge 1,000-node cluster, and they're still putting the data on the data warehouse. Why? Because probably the data warehouse was there before the big data, and you already had some, maybe I'm just guessing, but probably what everybody has, no? There was already a data warehouse. And still something you felt. Since you had the data warehouse and you put a big data platform on the top, still fit me in the data warehouse because it was a legacy system, it is still there. And there's still a lot of people that want to keep it like this, okay? So the big data platform is something that filters or transforms a very big amount of data into something that is analytic, and then you put it in the data warehouse because that's how I'm used to, and all my analytical tools are on there, okay? So I put it there because of this is actually happening. But there is no fundamental reason why we could not kill the guy, okay? And now more than ever, that stuff like platforms like Cloudera are supporting, they're very different workload. It's past the time that we could not update stuff on Hadoop. Now we have Kudos, we have stuff like this that you can do upserts and updates and stuff like this. And there is also no fundamental reason to keep it when you have tools like Arcadia Data, that you just can kick it out, okay, and just leave it in the data warehouse. Still, probably you're gonna do a bit of optimizations to write it in a nice format organization, but you can keep it there. But let's keep it there for a while because probably most of you still are keeping it there. Then I have added, let's try the laser thingy. I also added a data virtualization. That is a box. I had issue with putting this box. This box is data virtualization tools like Denodo that are just bridging different sources into unifying a single data point of access to all the data. But they also, we can also put in all this in this box other tools that are basically creating data access layers that optimize the access to the underlying figures. And in that box, we could talk about Dremio at scale. And even stuff like Arcadia Data, we could actually put it also there. So this is a very abstract term and box, okay? But all these different tools that help optimize access to various sources. And the sources could actually be directly. Sometimes, that you can also put it directly there. Okay, and then they claim they can do real time because they can get it directly from there. And then on the bottom, we include the dashboards that we had before. We will always have descriptive analytics with just give me the distribution of my past sales, okay? But now we also, and more often, we find that people ask for machine learning, advanced analytic predictions, and stuff like this, okay? And there are a lot of use cases that are on there, and more, and Mark, that is our top data scientist, he can say he's spending half of his week talking about this with potential customers. They are all interested about this. Anyway, don't have to do that. I can do this. So Hadoop is all over the place, okay? Be it in an open source, Cloudera, Hortonworks, Mapr, pretty much you can put Hadoop in there and do almost everything except visualization, with the exception of Arcadia, okay? But Cloudera can do, or Hadoop can do, all the batch ingestion, real time, all the different processing, all the different workloads. The only thing that there's missing is a bit of the visualization, okay? So we are done, no? Just use Hadoop for everything, no? If we would use Hadoop for everything, we wouldn't need all these different tools that are out here, okay? It's probably all of you have seen this image. We have also seen this image. I'm a follower of this image, and I'm still looking for the 2019 version. But it's a very good representation. A lot of these tools are based on Hadoop, or it's not at all my picture. I see some pictures. I mean, there's a very famous guy that, well, for me it's very famous. Maybe it's not. Maybe it's even in the room. Anyway, so how do I choose from all these into the ones I need? How do I choose? Okay, I have a Hadoop cluster, but I really, I suck at Spark programming, or I don't want to deal with Kafka because I don't want to program. What do I do? Okay, this is the content of this talk. So if you were looking for another thing, it's maybe you're wrong room. Okay, so of all the big data technologies we have, and there is a representation there. I also missed some technologies there, but I think it's pretty good approximation to the whole landscape. I still, however, like to do my own distribution of that landscape, and I like distributing it in these 4 sections, which is very, very much similar to what Matt Turk is doing, okay? The first thing for me are the platforms, the engines, okay? The things that are storing the data, moving it, okay? And in that category, again, for me, it's the best word to describe it is the engine, okay? So as engines, we have Hadoop, we have the storage solutions, we have the data processing engines, we have the massively parallel distributed databases or query engines, we have NoSQL, we have log and search stores and analytic solutions, we have streaming, we have then Kubernetes and similar cluster services, and then we can also have special systems based on GPUs, okay? But those are the engines. Then you can, some of these engines, like Cloudera, they ship with a lot of tools to make them work. But as I said before, some of them are quite tricky, and if you want to build your own solution based on them, you will take like forever. Okay, so a lot of people look at these other 2 categories to help them when they have to do data engineering and data analytics, okay? So the second category is data engineering. There are tools that help you when you need to deal with data engineering tasks, okay? Be it integrate and ingest data, transform it, be it creating virtualizations or single data access layers, okay? There are all these different categories of data engineering tools. And the other category is data analytics, okay? It's when you already have the data in some model that is suitable for analytics, and the tools in here has helped you to put it in that way. Then there is a lot of different tools to choose from to do visualization, to do data science, to do computer vision, to do speech and natural language processing, as well as log and social analysis. Okay, and there is also a lot of tools that are very specific to certain domains. So I talked to some guy here, I don't remember who was it that was in a hospital, maybe you? You work in a hospital? No, probably you have big data technologies that I'm not aware of. I don't know, there are some names here that specific. Okay, I'm not gonna touch those ones because honestly I don't know them. then basically, we have all these cross-infrastructure solutions, which are basically the cloud providers that have their own solutions as engines, as data analytics platform, as data engineering tools, as data analytics. So Azure have here all the HD inside. You can, in the end, it's with a virtual machine, you can do whatever you want and create whatever you need. It has data engineering. It has data analytics, have Power BI, all these tools, all these on Amazon, the same Oracle, they all have their own preference and they cover everything, okay? And then I also like to put Hadoop on the bottom of it because really Hadoop is mostly on the engines, but even HD Insight, I guess most of you know it, no? But HD Insight under the hood is Hortonworks, which now will be Cloudera. But today they mentioned that they didn't know exactly how that's gonna look like. And most of the well, Elastic MapReduce in Amazon, I think it's based on MapR, if I remember correctly, or something like this. Yeah, I see some nodding, so I think yes. So they are all these different technologies around the hood. Hadoop or very similar to Hadoop, or even the Azure Data Lake Analytics in Azure, it's very much similar, like Hive, okay, but with some different dialects. So the concepts of Hadoop and the underlying way Hadoop works is really used in a lot of the platforms up there, okay? So we do another subdivision of this, okay, which is, I do this because then I'm gonna cover tools that help you in all these different places, okay? So the first is tools that help you in the whole integration, ingestion, and transformation of data, be it on batch and on real time, okay? Then we have a bunch of tools that help you. Again, this is it's very hard to put them in one single category, no? But all the tools that help you in data virtualization, federation, in creating single data access layers, in optimizing underlying sources when you want to access directly. Okay, there are a lot of tools that help you there. That's for the data engineering part. For the part of analytics, I divide it in three. Okay, the tools that are for data visualization. Okay, the tools that are for data science and machine learning, and the tools that are for others, which is like log aggregate, log search, and stuff like this. Okay. And then I'm also gonna just briefly touch the offerings in the different cloud providers and Hadoop. So this is, as you see, is more a review of the different tools out there. So you need to choose a tool. No, there are. I mean, again, a very broad definition. There are two options. No, you pay or you don't pay. If you don't pay, you're gonna choose the open source free. There are still some choices, and then you're gonna have to end up developing your own custom scripts. In the case of machine learning, and that would be R or Python or TensorFlow, stuff like this. But you need to code it yourself. Okay, that's pretty much a very valid approach, and a lot of people is doing it. And probably you're gonna find out that if you want the best result, you're gonna have to do that. Okay. The other approach is to use a commercial application that has a nicer interface, a very visual, beautiful thing that you can use. That it's with with boxes that you can plug together, and those are very easy to, usually very easy to use. But there is always a sacrifice and a compromise you need to be aware of. No, the easier the interface, probably the more sacrifices you're doing in the flexibility of things you can do. Okay, and that's something that pretty much I think everybody knows, but not bad to remind you. So this is already updated since this morning that I saw the new Cloudera, the upcoming Cloudera data platform, how it will look like. But for the point of what I'm going to say, it makes still sense, okay? Cloudera and now the new Cloudera, the old Cloudera and the new Cloudera are platforms that have tools to do integration of data in real time in batch. They have tools to do different storage models from relational to NoSQL, to search, to the regular file system. Okay, it has tools to different workloads like application, analytic database or data warehousing like Impala, the Solar for search engine, the different tools for doing batch processing with Spark, MapReduce, Hive, and the Stream with Spark SQL. It also has tools to have a friendlier or easier to use interface, which is Hue, and there are Uzi as a workflow scheduler. Okay, so with just Cloudera and more with the new Cloudera that is also integrating the Cloudera data flow, as I'd say, you in principle have enough to keep your work to do whatever you want to do. Okay. Just for completeness, now they are merging, but Hortonworks also had the HDP and the HDF. The HDP is similar to or was similar to the slide I showed of Cloudera. Okay, there are tools to do everything in there as well. Okay, with some minor changes, like okay, in Cloudera you go for Impala. Here you go with Hive LLAP. In Cloudera you go with Cloudera Manager to manage your cluster and deploy it. In here you would go with Ambari. Okay, and so on. There are some other minor differences. One of the things that Hortonworks had that was kind of missing in Cloudera was the data flow, okay? And that's actually the very first thing that Cloudera incorporated. That was as Cloudera, the low-hanging fruit that they first took and put it in the new Cloudera is the Cloudera data flow. So that was announced a few weeks ago, and it's basically putting into Cloudera NiFi, Minify, the Streams Manager, and all these different things that are so popular and used in Hortonworks now will be also in Cloudera. Okay, and those are the tools that are available in the new Cloudera, and it's already a very, very complete solution. No? So why do we care about other solutions? Okay, because basically it's a matter of taste. Okay, you may be happy with it, and you are I'm fine with Uzi and the workflow scheduler. I'm fine with creating my own visualizations on JavaScript, or maybe using Power BI or another, more traditional BI tool. But there are tools out there that will facilitate your life when you are dealing with data engineering, visualization, stuff like this. Okay, and we will get to them. Okay. In the cloud, you can always create a bunch of virtual machines and install Cloudera, and then you have what I just mentioned. Or you can use the native platform as a service services that you have on the different public clouds. I include only here Amazon and Azure, okay, but you could have a similar picture, for example, with other cloud providers like Google or even the Oracle Cloud, okay. For the ones that don't know, I guess a lot of people know about it, no? But one of the differences when you go to using PaaS is that all the different, let's say, I don't want to say the animals on the ecosystem of Hadoop, but the different workloads or platforms that are integrated into a single one are separated into different services. So in the cloud, you have one service that is the data lake, okay, for example, the Azure Data Lake Store. That's just kind of HDFS, bare HDFS, okay, pretty much, which is the same. Well, no, the S3 is slightly different, okay, but for the sake of my point, let's get with Azure, okay. Azure Data Lake Store is pretty much HDFS, but it's only HDFS. You can do nothing with it. You need something to get the data from HDFS, process it, and write it back or stream it somewhere, okay. And that's where you get HD Insight that allows you to create clusters with Spark or Hive or Kafka, and you basically need to choose. It's a Spark cluster or a Kafka cluster, okay? You need to choose, and then you can even have different HD Insights, one for Kafka, another for Spark, and they actually need to be different. You cannot have one HD Insight with few of them, as far as we know, as far as I know. Still, you need to create the cluster. There are stuff like Databricks that is somehow, well, no, I don't want to say similar, but because Databricks gets you the processing engine with Spark, but it's the Databricks are the guys that are maintaining pretty much Spark right now. I think, well, not only them, but a lot of people in Databricks are pushing Spark. So the coolest Spark you can have is going to be on Databricks. Okay, that's one thing, and it's going to be, the super coolest, efficient Spark you can get. And another reason is that they basically incorporated all this kind of notebook working like in their platform. So it adds something on the HD Insight, okay? Another alternative is using Data Lake Analytics, which you give directly in this case is USQL, that's a dialect, their own dialect, and it will process you don't need to think about clusters. Okay, so there are these three options as processing engines and something more in the case of Databricks to do data on the data lake. And I'm just covered the HDFS equivalent and the processing engines equivalent. Again, there are many more. There is the whole streaming thingy, okay, which is the Events Hub, which is basically a Kafka as a service, and then the Data Lake Analytics, what is it? Where is it? Stream Analytics, okay, which is to stream analysis, which is to create, again, with similar to KSQL, okay? And so you have all these different services that you need to start, and probably you end up with simple deployment. You end up with 5 or 6 of this one, a data lake, it's the inside, probably for some pipelines, an Atla and a data lake analytics. If you have a Lambda architecture, you're going to also have a Events Hub. So you will have 5 or 6 different services, which is cool that they don't have pretty much management effort that you need to put because they are serverless, kind of, okay? But still they are different, and when they are different, also one thing that probably they don't mention Azure is like, governing all the security gets a bit annoying. When you have different platforms, all the management of all the security, it's a bit annoying. That's one of the things that Cloudera with a unified platform tries to tackle, no? With having a governed access to data and security. One of the other cool things that you can have in these cloud providers, if they already have a lot of built-in, it's maybe too small for you to read, but don't need to read everything. There are a lot of services. For example, if you want to do image recognition, you don't need to reinvent the wheel. Basically, most of them have APIs that you give them an image, and it says if it's a car or it's a cat, okay? And it's already there. You can use it if you pay. So I was surprised to know that a lot of people don't know that. No, there are there. So if your issue is identifying cats on pictures for whatever thing you are doing, I wonder what that may be. But there is an actual already solution for doing that. Okay. So now moving into the different boxes and tools that may help you when you are doing data engineering. Okay. The first box I'm going to tick is the tools that help you in ingestion, integration, transformation, and extract Hadoop load, okay, with all these transformations within Hadoop. There are many tools out there. Okay, I'm going to highlight 3 for batch and 3 for and 2 for stream, and then Azure as an option. Azure Data Factory as an option on Azure, native option on Azure. Okay, Talent and Informatica, and then I included Kettle because we are using out of Kettle in house as well. Okay, those are basically these 2 guys are. If you look at the Gartner quadrant, they are on the top right. Okay, and they are tools that you can use when you want to do your batch ingestion and processing and loading into a vertical data warehouse, or you want to keep it in the lake, but you want to do from all this batch processing, but you don't want to code your own thing. Okay, so all these couple of tools have these nice interfaces, and we will see one of them now, Talent, that with basically just configuring a couple of boxes and putting them together, this thing translates into native code that will run on the cluster, and then you end up creating with just some clicks and some configuration parameters, basically a batch pipeline without actually having to code it. Okay, and Streamsets and an Apache NIFI is basically the equivalent in streaming. Okay, you can do streaming pipelines without coding them in whatever language, just with simple boxes that need to be filled in with configuration. Okay. Talent, the main product they have is the Talent Data Fabric, which is a single solution that incorporates all these different things. So from the data integration to the data transformation to the govern to the data quality management, it's a single product to do all the different things Talent do. Okay, we're just gonna demo now Talent, the open source studio. Okay, Talent has Data Fabric, which is a paid product, and it has an open source component. We're gonna demo that one, so you'll see just a couple of minutes. Mark will show. if you want to start loading, I'll keep talking and you can. Hem de surt aquí, sí, surtem aquí i posa això. So this is Talent. Is a desktop tool, okay, that you will need to install on your depending on what you want to do. It need to be a powerful machine, or if you are only using it to orchestrate stuff that will be running on the cluster, then it can be a light machine, like this laptop actually. And as I said, this is the open source solution, and of course it comes with limitations. The connector wide, it has connectors to I think they don't, the connector, they are all there, or most of them are there, I think, no?
The connections, they have a lot of connections, over 100.
The main limitation this thing has when you want to work on Cloudera or Hadoop is that the boxes that you can translate to native code are only in MapReduce. So the free version does not translate these boxes into Spark, which is something you probably want to do. Okay, so so the example we're gonna do, or Mark is gonna show now, is translating into MapReduce. But if you pay the Talent Data Fabric, it can translate it to Spark. Toteo.
Yeah, so Talent, as Oscar said, is an ETL-like tool for big data. No? So it translates these boxes into Spark code in the paid version, or to Hadoop in the free version. Okay, so this was an ETL we did for a project for a bike sharing system, one of our clients, and we wanted to move data from different data sources, from flat files, from Hadoop, from HDFS, and also from relational databases. And we wanted to move all of this data into a Hadoop cluster, okay, into HDFS, and to create tables in Impala, and then we can visualize this data in a visualization tool. Okay, so the tool itself, in the left-hand side, you have all the jobs you have designed. Okay, then you can drag and drop in the middle all these transformations you have in the right-hand side. Okay, so for example, you have aggregate rows, or convert the type of any data, or filter some rows, any kind of transformation you would like to do. You can just drag and drop and move it to the middle. Okay, so this was the main ETL: extract, transform, and load. You can go inside each one of these jobs, and then you'll get all these boxes, which you can define the connection to HDFS cluster, and then you can make some transformations, as I said. Okay, and how to make these transformations? You have here you can set all the parameters you need. So the string to the path, or where you have your files, how the files are separated, the rows are separated by any specific character. So you can configure all this transformation just by some clicks. Okay, so you don't have to code anything. That's the good thing of the tool. Okay, yeah, pretty much, Oscar.
So this was just a quick look into Talent. The other tool we wanted to demo is Streamsets. Streamsets is a tool that today I when Cloudera and Horton was merged, and Cloudera basically got the Cloudera data flow, Streamsets received like a punch, no? Because before this, Cloudera was always telling Streamsets is a very good tool, and now it's they are I understand that, no? They are positioning Nifi. For me, Nifi is it's actually an excellent tool, and it's very oriented on the IoT, or and it gets with the message now of Cloudera, no? From edge to AI. Streamsets, I think it's not so strong on the IoT part, but on the interface and using the tool, it's very nice, and you can very easily create pipelines, and the interaction with the tool is fantastic. Streamsets comes like Talent with some components open source. The main and the most important component is open source, and it's the Streamsets data collector, and that's kind of a worker that you put on some machine, on a laptop of Mark, for example, and that worker you can configure it with boxes to get data from some place, transform it in the laptop, in the process, and put it somewhere else. So it's very normal that you have an Streamsets pipeline that is getting data, transform it, put it in Kafka, for example, and then you can create another pipeline that gets it from Kafka and put it somewhere else in a Kudu table, for example. And this is actually the demo that now we're going to show. That is the Streamsets data collector. The enterprise product of the Streamsets is this data ops platform, and the coolest addition to all of this is the Control Hub, which is it's a solution that, well, basically when you have the open source and you have only one pipeline, it's fine. You just do it. You just need a couple of workers. You can install them manually and configure them manually. But when you start scaling and you start having more and more pipelines, and you need to have different workers doing different jobs, if you do that with the open source, you're gonna end up with a headache because you're gonna have to maintain. And that's when the Control Hub kicks in, to have a centralized place from where you can manage all the different pipelines and say, okay, this pipeline I want it in that worker, that pipeline in that worker. This pipeline actually it's parameterized and I want them in this, and this worker. Okay, and this is very, very cool from Streamsets. So now we're gonna just demo the open source component, the Streamsets data platform, and just it's very, very simple demo, but it gets an idea of what you can achieve with Streamsets.
Okay, so this is Streamsets. We use this one to collect data from a URL that was giving a JSON file from this bike sharing system. It was the station status of all the stations in a city. Okay.
Right, New York in this case.
In New York, yeah. And how we did it? We just drag and drop some of these components. You can configure here, for example, the URL that is giving you the JSON file with this information. And the magic of this tool is that you don't have to code anything in Kafka, which is very painful and maybe difficult, right? You just drag and drop these different transformations. In this case, we took this JSON file, we flatten it because it has hierarchies, the file itself, and then we push it into a Kafka producer, okay? A good thing of this tool as well is that you can preview how the data will flow into the Kafka or whatever you have at the end, okay? So you can see if there are errors and you can modify your pipeline on the fly, okay? So yeah, and the other pipeline was taking Kafka to Kudu, okay? So one was collecting data, putting it into Kafka, and the other pipeline was taking this data from Kafka and pushing it into a Kudu table, okay? Kudu table was updated every time that it was receiving new data, okay?
Okay. Thanks, Mark. So again, this was just quick demos of tools that can help you when you have to do batch or streaming pipelines. We saw Streamsets, but I thought about showing Nifi, but then I checked the agenda and there is Nifi all over the place. So you were gonna end up seeing Nifi one way or another during these days. So in the end, I decided to just include the Streamsets for this demo. Okay, I'm not gonna go much into this box, okay? Just show you a few names of tools that are there to either do data visualization or federation of accessing data, or just to create data access layers that are optimized, okay? And in these tools, in this box, we can, the nodo is in the data visualization Gartner graph, it's on the top, okay, the nodo. The nodo is, for the ones that don't know it, it's a tool that let's say the main use case they want to solve is the so-called spaghetti ETL. When you find yourself that the ETL pipelines you need to do look like an spaghetti from the from the outside, it's maybe a place for Denodo. Okay, it's also a place for Denodo when, for example, you are dealing with 15 data warehouses because you had whatever you were a company and you merge with other 15 companies, and then you end up with 15 data warehouses, and you want to create a single centralized data warehouses. What do? You can either start everything from scratch and reinventing all the pipelines, migrating all the pipelines, or you can create a logical data warehouses that just it's a logic combination of all the different data warehouses, and that's where Denodo is great. Okay, to combining, for example, 15 data warehouses into one single data warehouses. Denodo is set to not make copies of data, though it has a caching mechanism that you can somehow you can program, and you should actually program to the best of your for the best of you. There are probably guys from Dremio will kill me for putting them in this slide, and same with AtScale and Denodo, because again they are different tools, okay? But I didn't want to put like 5 different slides of one virtualization, one for optimization, okay? Dremio, probably you've heard it. Is a tool that this is tricky to say, no? But it's a tool that it's a system that you can put as an entry point from when you want to access different analytic sources, and these analytic sources can be either source systems or maybe a data warehouse that is already done, or a big data platform with a data lake or whatever, okay? And then you want to have one single solution that is the single place you go to access this data, and in the process, Dremio will get the data, and depending on how you are accessing it, it will optimize and make a copy of the data for later optimal access, okay? AtScale is doing something similar, but it's creating all-up cubes for the data access, okay? And then in Azure, there is something called the Azure Analysis Services, which is also something slightly different, okay? So there are all these different tools that they are doing slightly different things, and that for specific situations in when you find yourself, again, with 15 data warehouses that you need to combine, or you find yourself with a data warehouse, a data lake, and something, but they are all very inefficient when accessed, and then you need a central place that helps you optimizing this automatically. All these different tools can help you in there, and if you want more details, I guess some of them are around DataWorks, and they'll be happy to talk to you, or again, talk to us, that we also touch a bit of them. Okay. Now visualization tools. I've seen some of on some Cloudera slides and some Cloudera partner events a while ago. You see the Cloudera cluster, and then on their, since they know they don't have a visualization tool, they put on the right of it, they put Tableau, Power BI, Click, Arcadia Data, and Zoom Data, and they all work with they can all, in the end, they can all talk to Impala. Impala exposes a JDBC, so actually everybody that gets an JDBC can talk Impala. Okay, so you can, of course, plug your traditional BI tool to Cloudera, so be it Power BI, Tableau, Click, or the Oracle Business Intelligence, because again they have either natively or via installing a Impala driver, they can get Impala. But these tools were tools that evolved. So they were tools that they were created where there was not Hadoop or whatever, and they evolved to basically include it. But they don't really, they are not meant for it, okay? You can still use them, but they are not meant for it. There are other tools, and here I name Zoom Data and Arcadia Data because we are the ones that we are proposing to our customers and that we use. Those tools are specifically built for big data, okay? They solve some of the limitations that the tools on the top have. One of the limitations, the first limitation is how you deal with physics, okay? In the end, if you have a table that is a petabyte of rows and you want to query something onto that table, imagine that table is, even if it's partition, but you want to aggregate the whole year, okay? You need to deal with 1 petabyte of data, no? How do these guys, on the upper part, you're gonna be 1 hour and a half or whatever, waiting for the machine to get the response, okay? So Zoom Data and Arcadia Data, one of the things they deal is how they solve the physics, okay? And they took it in two different approaches that we will see later, okay? And they are both very elegant and very valid for what they do. I also included D3 and eCharts just for the ones that wanted to go for a free open source solution. Okay, you can always use D3 and eCharts, which are very nice, cool tools to create visualizations and create your own visualizations. Okay, but today I'm gonna focus on Zoom Data and Arcadia Data as the tools that are really done for doing big visualization on big data BI. Okay. I'm going to start with Zoom Data, and then I'm going to go with Arcadia Data. As I said, Arcadia Data guys are here in the room, so later if you have questions about it, either me or Duncan can help you answer more questions. First, Zoom Data, okay? As I said, Zoom Data and Arcadia Data, they are different. So they deal with the problems of big data visualization, like dealing with physics. The other is dealing with streaming data, or dealing with sources that are not traditional relational sources, okay? And they both solve it, okay? Zoom Data, I'm going to mention 3 very cool features that Zoom Data has, okay? The very first feature that Zoom Data has is something called the data sharpening, or the micro queries, okay? Which is basically when you are running this query that will process this petabyte of data, okay? While other BI tools will be waiting for 1.5 hours to get a response, what Zoom Data has, it gets this query and it splits the query in micro queries, okay? And basically, instead of trying to query the whole 1 year, basically it's querying days and it's doing it randomly. So it will start querying one day, it will start doing random hitting the data and getting answers. So within seconds, you already get some first results. And you will see, and we will see it in the demo, you will see already some result that within seconds you will see data flowing into the screen. It will say reading 3%, and it means only 3% of the data is there, but you will already start seeing something on the screen. And somehow this, and most times, with just waiting a few seconds, you will get the information you need to take a decision and probably navigate and drill down to some other dimension, okay? So Zoom Data is a tool for this explorative, agile explorative experience on big data sources, okay? And the best example is what I just explained, the data sharpening. The other cool thing of Zoom Data is that it allows real-time visualization natively from, for example, a Kudu table, okay? And it has nice features like a DVR control that you can rewind, and you can go back in time and see the visualization back in time, okay? And we will see this. And another feature it has is the multi-source exploration and the data fusion, okay? You can get data in the Hadoop, but also data from other places, and define a fusion connection, which is basically fusing or blending. This is equivalent to the Tableau blending, okay? But it's just using a slightly better, or let's say lesser limited approach, okay? So let me just start showing you Zoom Data, and you'll see what I mean, okay? Okay, this is how Zoom Data looks like. It's a web application like Streamsets. Oh. Sí, eso que me ha sortido aquí. No. Thanks again. This is how Zoom Data looks like, okay? The first, I'm going to show you a demo to see how this data sharpening works, okay? Again, this is a demo that will, it's querying sales data on 10 billion rows, okay? And basically every box of this is basically doing Impala queries, okay? So now it's launching the query. The Zoom Data engine gets that query and splits it in micro queries and starts asking micro queries to Impala instead of the big one. And then it starts reading data, okay? I already have 5%, or we already saw the answer before. And we saw, okay, look, I already read 8%, and this is how it looks like. In the end, eventually, we need to weight the same than Tableau weight, maybe actually a bit more because there is some overhead of these micro queries. But now, maybe with 5%, you could already see what probably you wanted to see. In this case, you want to say, okay, I wanted to see the state that has the most amount of sales. No, okay, that's California. So I can already drill into California. I don't need to wait until the 100%. So I can zoom into now, let's say, the county, okay? And now this will kill the query, zoom into the county, and now I will have the information per county. So now we'll have Los Angeles, San Diego. Well, let's make it big so we see the names. Okay, so I will have this, and now I can continue to drill down and to navigate, and I don't need to wait until 20 seconds or 20 minutes for the query to complete. Okay, and this is pretty cool feature of Zoom Data, which is quite unique. All this visualization is very agile, let's say. The other demo I can show of Zoom Data is real-time visualization. For example, from, let me see, these ones. Okay, this is, again, sales from a store that in real time we can see that the data is moving. Basically, this is putting data in a Kudu table, and this is basically launching queries to Kudu. And in real time, we can see this is changing. No, we don't need to refresh; it's just updating. And this is something that natively can be done in Zoom Data, while it can also be done on Arcadia. But in the traditional tools, this is it's not possible to do it by default. Power BI has some real-time capabilities, but extremely limited and only from one specific source. So it's not really like similar to this. Okay, and to wrap up this one, we can show, for example, this is a cool one because with Zoom Data you can connect to search engines, and for example, Cloudera Search, which under the hood has Solar. So in this case, there was some web scraping done for auto reviews. So we got data from TripAdvisor and stuff like this, and we put it in Solar, in Cloudera Search, okay? Then you can plug Zoom Data into Cloudera Search, which basically, in the end, each element is a JSON with the review and some other information. And you can do stuff, basically you can filter on text, and you can do, I want to see the dirty hotels, okay? And this will filter the dirty hotels, and then you can navigate. You can know in London or in Las Vegas, in New York City, okay? So again, let's see, now, hope there is no, here, okay, those are the hotels, and the governor is the one, and for example, get me the details, no? So I want to see the actual reviews for this hotel, no? So review text, okay, and then you can navigate the data. So Zoom Data is a tool. It's basically I like the name, no? It's a visual analytics platform, okay? It's a platform that allows you to navigate the data and create it visually and create dashboards of this data. But it's more an analytics. It's more let's say an exploration tool, okay? Now we move to Arcadia Data. Let me make this. So Arcadia Data takes a different approach, though it solves some of the problems. Arcadia Data is an enterprise big data BI solution. Okay, it's something that you put as a service in the lake, in the Cloudera, and it's not something you put separated. Okay, that's unique in Arcadia. Arcadia is inside the cluster. That's the only one that does it, which means that all the data stays in the cluster, and you don't need to put copies of data everywhere, somewhere else. Okay. The way that it deals with physics, it's like Zoom Data does the data sharpening. The Arcadia Data took a different approach, and what they do is they have an engine called Arc Engine that automatically, when you start hitting let's say, executing queries, because you are having your dashboard and you start doing queries, these queries, Arcadia Data will say, okay, these queries are being executed, and then it will propose you something called analytical views that will basically create kind of pre-computed cache tables. For example, if that query is doing a group by, Arcadia Data will suggest, and actually, if you configure it, it can automatically create that group by, and it will be created and stored in the cluster so that the next time you run the query, that will be very fast. So it's a different approach to solving the physics, okay? But it's very elegant as well. And Arcadia Data as a product is it's very enterprise oriented, and the type of visualizations and the type of product you can get is very enterprise like, okay? And the feel and the type of dashboards you have, they are if you see an Arcadia dashboard, and we will see some of them, they look very nice, and it has all the features that traditional BI guys on the traditional BI tools will wait. You can have a filter bar. The type of graphs are even more than you can find in other tools. Okay, and did I more or less cover, Duncan, what you would highlight as? Okay. So let's see it in action. So this is Arcadia Data. This is the homepage. The homepage, again. Thank you. Yeah, if you wouldn't have mentioned last time, it would have been. Okay, now this is. I'm gonna even make it cooler. Okay, now. So this is how Arcadia Data looks like. It's a web page again. Okay, so it's something that you can configure to look it as you want. You can embed wherever you want to embed the dashboards or wherever you want to embed. Okay. In this case, we're gonna see an example of a fictitious telco. Okay, that is an Italian telco that was it was merged. It's a fictitious, okay, but it was the merger of two different companies. Okay. And for example, here we have the landing executive dashboard, which shows some KPIs, for example, the average revenue per user or the average cost per user. And you can even configure alerts. For example, you can define a threshold in your churn. For example, here there was a use case that was churn prediction of the customers, and you can configure an alert based on a certain threshold, like we here, for example, see. No? We see, look, my threshold exceeded. My churn threshold exceeded 3 days ago. Okay, let's see what's happening here. Okay, again, for example, you can have like I did. You click on some place on the dashboard, and it will redirect to another dashboard. This is something you also find in Tableau, stuff like this. Okay, this inner or inter dashboard communication stuff like this. You can all configure. In this case, I click on the alert, and it brings me to the Napoli churn graph, which is showing me in this case. No, and look, there are 449 customers that are predicted to churn in the next 30 days, which is 250 more than the previous run. Okay, and in this case, we have some examples of the distribution by customer life value. Okay, because I want to see the important ones are the hive. No, the hive. I don't want to lose these guys, and those are all these guys. These guys here, wherever they are, like 50 or 60 guys are predicted to churn. Okay, you can put filters wherever you want, and here, for example, we have filters by age, name, plan, the device type, and you can configure them as you want. And again, another example of dashboard communication. No, I would say, for example, I want to see this guy, and I click on this guy, and this specific guy, it brings me to another page. In this case, it says, okay, this guy called Calabro. This is it's actually, for example, here, in this example, we implemented a best action and a next best action, and it's recommending, okay, this guy, you need to call him and offer and propose him this campaign, the Hive customer life value, and so it's proposing this. This is giving me the examples, and this, for example, a cool example of one of the graphs you can see is the network of this guy. Okay, so this guy here in the middle, so it's calling to all this guy, to the guy 24 with this ID or whatever. We could have the name if we wanted here, and we can have details of this guy. let me go back to here. Okay. Here. So, here, I'm going to the data part where we can create the connections and the different data sets. In this demo, we have pre-configured some connections and data sets. In the type of connection Arcadia is the type of connection that if you configure Arcadia, this will, under the hood, will run Impala, but using this Arc Engine smart thingy that when you hit a query, it will say, okay, you are doing this query, why don't you create these analytical views to optimize its access? And again, you can configure to do it just automatically, okay? And those are the type of Arcadia connections. One of the other connections you can do are real-time connections, which is another cool feature of Arcadia. For example, here, in this case, we have connections from Amazon KSQL or from other KSQLs. And a cool example we can have of a real-time visualization is, for example, this visual here that is showing, for example, this one, cybersecurity on Congo. Okay, and this is getting data directly from, say this one, directly from Kafka. Okay, so Arcadia is the only tool in the market that you can directly plug from Kafka to visualize information. So now, as the Arcadia creates its own consumer and it starts getting data and it starts populating it here, okay? And we can see basically you can configure whatever you want. In here we are seeing some KPIs based on the Kafka stream, okay? So with this we show, again, what I could show in 5 minutes of Arcadia Data. If you want more information or more demos on Arcadia Data, talk to me or to Duncan, and we'll be happy to show you more and discuss more about Arcadia. For sake of time, I'm gonna move forward. Okay, so we saw Arcadia Data, and that was the last demo. Just for completeness, I'm gonna finish with the rest. Okay, there is also a lot of tools that can help you when you try to do machine learning and artificial intelligence with boxes, with easy stuff. Okay. The market leader is NIME, which has an open source, very, very complete solution for doing simple machine learning, or not simple, they can be complex, but in a simple way. Similar to NIME, you have Alteryx. Oracle has its own product called Oracle Data Miner, also to do machine learning with boxes. In Azure, you have Azure Machine Learning that we like a lot and we use a lot in-house as well. There are others like Dataiku that is, it goes beyond data. It does that, but it also does the whole end-to-end from ingestion. Also, it has some ingestion and transformation capabilities and also some dashboarding capabilities. So it's slightly different from the top. And then, of course, we have the open source approach. No? You can always get R, Python, TensorFlow, and do your thing. Okay. And last but not least, in here. There are other tools. In the end, we could talk about a lot of them, but I wanted to include Splunk because it's something that I've been hearing a lot, and I've had customers to which I was so hardly trying to position Cloudera as, do your log analytics with this, but people, they are going into Splunk. So I just, if you don't know Splunk, it's also it's a tool to consider. It's a tool that is meant to do analytics on log data, okay, but it's now going beyond that, okay, and it's a very interesting tool, but I don't have time to cover it now, but just look about it. So I just wanted to, this meetup was to do a review of all these different tools, show the ones that we like a lot and that we position. If you have some more questions or just look around or ask us or ask the different vendors. If you want to, when you need to choose, the considerations in the end, those are 10 tips that I give. It's like, okay, first, what is your budget? Can you afford a commercial, or is there ways, or you really want to go for open source? What is your deployment model? Are you on cloud or on premise? Because depending on the tool, you may not be available on premise. If you are extremely in love with Azure machine learning, it's gonna be on Azure. It's not gonna be on premise. Very important, what you want the tool for. If you want to do a very complex pipeline of batch processing, yeah, Data Echo can do some processing, but it's not super complete. So depending on what you want to do, there will be a tool that will be more suitable for you. Very important also, what are the engines? What are the platforms that this tool needs to talk to? Because not all tools can deal with Kafka, for example. No? If you really want to visualize Kafka, Arcadia is your tool. If you want to get data from, let's say, Edge, from a Raspberry Pi, then Nifi or the whole cloud data platform is the only one that has Minify, which you can install something. So there is, depending on what you need to put your tool or what are your engines, that may be one thing or the other. Similarly to this one, what are the limitations of the tools? No? Not all the tools can do everything. The user interface. There are tools that look nicer than others. Don't get too distracted on, okay, it's very important the appearance, but it's not everything. There are tools that maybe don't look as nice visually, but they are the actual tool is probably maybe better than others that look maybe uglier. Okay, so don't look beyond the surface. What are your company-wide? What are your governance and federation policies? Because that's a concept that, well, something that more and more people are talking about. Oh, no, I want to govern policy when accessing my data analytics sources. Most of the tools and the visualization part, like Arcadia or some data, they all can help you in that, okay? But there are some more than others that are taking this more serious, okay? Very important, what is the expertise of the guys that will do the job? What is the performance requirements? And lastly, are you okay with having 1,000 tools for the job, or you want a monolithic solution that with one tool you kill them all, okay? Because that's also possible. Okay, so to wrap it up, after choosing your platform or your engines, the next step is choosing the tools to work on these engines, okay? And depending on what you choose, it will ease your life. There are a lot of choices, and we just cover a few of them. I hope we help people in the room. We have used in ClearPix a lot of them, so don't hesitate and come contact us. I'll be happy now to share some cards, business cards. And now just talk to me now. We'll be around still for probably at least half an hour and maybe an hour, so if you want to talk. We have some offerings in ClearPix that are exactly meant to help organizations that are now looking for a platform or a tool that can help them in any of the let's say, edge to AI, right? From the beginning to the end of the end-to-end analytics life. So don't, again, contact us if you have any question. If you have any question, now is also a good moment to ask them. Is there questions in the room? You can just, yeah.
You showed in the first demo this result sets and NiFi. Actually, it's very hard to decide between these two, but what is your recommendation that, like, what are the strengths and weaknesses for both of them, depending on your use cases?
Again, as you said, it's very hard, and in the end, it's a matter of taste. No, there are some. If it's a pure IoT scenario, then it's easy. It's called Data Flow and Nifi, because in Streamsets there is nothing like Minify. Minify is something that it's heavy as I think 10 megabytes or 20 megabytes. You can install anywhere. Okay, Streamsets it's not an edge tool. Okay, Streamsets is not really. So there are some cases like IoT that I have a clear answer. Then for cases that is not IoT, then it's not so clear. Streamsets for me looks easier. It's easier to operate. It has the whole monitoring of the pipelines is something cooler than what you have in Nifi. Okay, but Nifi probably you can again as it goes a lot like this. The ones that look nicer sacrifice a bit of flexibility. So in Nifi, you can go a bit down into the tuning of the pipelines and stuff like this. And for example, one example, in a Streamsets, you have one box that talks to another box, and the pipeline, the actual pipeline, you can do nothing. In Nifi, you can even do stuff on the on the connection between two boxes, which is something sometimes you want.
But in your recommendation, which one is the more powerful when it's a huge amount of data we have to stream?
An iffy. Any other question?
For recording, what is your recommendation for the open source free versions?
Sorry, what?
For the recording purpose visualization layer, non-commercial one.
Well, in-house we do a lot of projects that are customers that don't want to use any of the commercials, not because they want open source, because they want some custom thing that you cannot do in other ways. And we basically is what I said, D3 and eCharts. That's the two libraries we use.
Tell me please, what version Hadoop, HDP, and HDF you use in your company?
Sorry.
HDP, you use HDP for DataWorks. HDP versus HDF.
Which version of HTTP do you use?
We basically always use Cloudera in our company, and we were Cloudera partners. Yeah. So I'm now learning a lot. I was Streamsets using, and now Nifi is like, okay, now I need to learn about Nifi.
I have the same question on this virtualization, because normally all these virtualization tools, whether it's enterprise or open source, in analytics tool you have like, you can drill down and all those things, and mostly this tool is for business users who doesn't have much more, technical insight of the data, like how data look like and all those things. But in this underlying Impala or Hive, you have like really, which has a lot of impact. And in our organization, we are actually facing problem of the performance, because like the Hive queries that Tableau generates, they are not optimal for all kind of use cases.
Mm-hmm.
And
You should talk to this gentleman here.
yeah, do you recommend some kind of acceleration layer? Like we have tried Jethro, we have tried Presto, and now we are still like sometimes query takes like, if business user is like, yo, I want to see all the customers with this, it takes like more than an hour.
Yeah, I mean, Duncan will probably, when we finish, he will jump at you and talk. But Arcadia Data can do that, and it's a very good tool at doing that. That's one of the use case. That's one of the niche, or how these guys tackle it. Basically by creating these analytical views. They get this query, they automatically get this expensive query, and they suggest, and again, you can configure to just automatically do it, create cached groups, buys, and stuff like this, and they store efficiently in Parquet and in the same cluster. So the next time you run the query, you will get that pre-cached stuff.
But instead of tackling that question from the top, there is nothing from the bottom that we can make the acceleration on top of Hive, or we can use some other tools to make it or optimize the queries which are coming from the.
No, but what they do is they optimize on the bottom. They actually create a new a new Hive table that is a pre-aggregation that you need for that query. So in that query, you're probably gonna do a group by, blah, blah, blah. So they take that query and they materialize it on disk, store it in Parquet, and the next time you get it, it reads it from that cache.
What size of your Nifi cluster?
What size is my Nifi cluster? I don't have any Nifi cluster.
No?
No.
What do you use? In what cases you use Nifi?
No, I mean, me particularly, I don't have any Nifi cluster right now, because as I said, we are more on the Cloudera part. So we don't have any Nifi cluster right now. We were a Cloudera partner with the Cloudera stack, so there was no Nifi. Not my customers don't have that. Sorry. Yeah, go ahead.
You spoke a bit about talent in shoulders, but you also said you use Canva.
Mm-hmm.
What would be your opinion on the tool? You talked about a bit about the performance and if you noticed some difference in the performance of the generation.
Well, Danny, Kettle versus Talent, something you may on performance-wise. In the end, they both. In the end, they both, and Informatica are the same. They translate whatever box into native code. Performance-wise, I mean, depends on the pipeline. We have not performed a benchmark to do exactly the same on the three and compare. So I cannot give you an answer. Three of them translate to native code. As far as I know, Talent transforms into Java. You know more than I do.
Both of them work in Java, really. at the end what you're doing is just programming a visual interface, and not coding Java. You can do it if you want, because you can create some Java custom code. But at the end, you're just putting boxes in a grid, and then that's all Java code is working both in Kettle and in Town.
More questions? No? Okay. Yeah. Go ahead.
What about metrics? So like to get the performance of the Spark job or something like this, do you recommend a tool for that?
Well, to be honest, I am a guy that goes into the Yarn web UI and start drilling into the history server and all these things. So that's the stuff I do actually. Even if I use Talent or whatever, they have some monitoring tools. But if you really want to hit harder, you're gonna have to end up going to the resource manager and the mapper and stuff like this. And all these tools you can kind of make a bit of configurations on the actual job that will be run on Spark. So like from configure num executors and stuff like this. If you drill, if you take all the layers.
Concerning to the data quality as well, like so if we are going to create a Hive table from the Spark code, then how to check this data quality on the Hive table?
What do you mean? Give me an example. What do you mean?
For example, to check if there is data already, or there is some specific data quality, like I don't know.
Well, in all these tools, you can embed all this logic in different boxes, and you can make these graphs as complicated as you want. If this if this field is null, do this, and if not, do that. You can do all the logic you want with all these boxes, and that will translate again into whatever code. Some more question? Well, then thank you all for joining us. There are, as I said, in t-shirts there from Arcadia Data. Please feel free to get them. They are sorted from small to extra large. And the lady there is Deborah from Arcadia, who will help you. As I said, we will be around here, so if we want to talk more, just come and join me. Thank you.
Oh, welcome.